heard Fintech personalization talk, right? So this is something which you would relate to on a daily basis. The title of the talk is it's Convergence of AI and Blockchain, what's the deal for Fintech? So we are drawing parallels from the AgTech industry. Right? So there are data oligopolies like Google, Facebook, Amazon, and this is like the big data, right? So all the data is collected in centralized server farms, and you send the models, the AI models are run on the servers, right? So on the data centers. But what is life after Google? Right? Because this is inherently with blockchain, we can visualize or we can imagine that it will lead to decentralization, because now the AI has a platform, a DLT, to talk and communicate, right? So can we imagine an architecture where instead of sending the data to the model which is on the centralized server, can we pull the data to where the model is on the client side, right? So in IoT, there are terms like edge computing, where the intelligence resides on the edges instead of it being resided on a centralized server. So this book, which I found, is George Gilder, dates this further, saying this idea of the web, where it was meant to be a decentralized platform, was led to data oligopolies like Google. So what is life after Google, right? So the life after Google is basically the disruption of the centralized data model through blockchain economy and decentralized AI. So when I typically present this topic, people immediately understand the use cases or applications when I talk about, let's say, your Swift keyboard, right? So whatever you type in your Swift keyboard on your Android or iOS phones is like, typically you get predictions, but those predictions are inside the client, right? So Google or let's say Apple cannot really send whatever you're typing to those centralized servers like they typically do in Google Assistant or Amazon Siri, Alexa or Apple Siri, right? So whereas in the Swift keyboard, what exactly is happening is the predictions is happening locally, and only the weights for your whatever you type, right? Like say I'm going to Nepal is like a relevant prediction for people traveling here, whereas in a different place it might be going to some other word, right? So that model is like none of those words are sent to the centralized server. It's just the weights are adjusted for the meta model, and so that meta model is what, let's say, is pulled from a decentralized storage place like IPFS in case of a blockchain architecture, or right. So and these models are encrypted. So your data and the model is pulled to your local instance and trained to become better. So the weights are adjusted from what you are typing, and the local client gets better and the meta model gets better. So there is no centralized place where the models are stored and hoarded by these data oligopolies. Right? So this is what George Gilder refers to with the blockchain leading, and he stops at blockchain, but if you read the current literature, it's also about the AI, which will not just give you a DApp like in a blockchain economy, but also to DML apps, right? So you have decentralized machine learning apps which are powered through this new paradigms, which will lead to the enablement of decentralized recommendations, all the features you are already used to, powered by AI in a decentralized way. Right? So moving ahead, so what's the deal for fintech? What lessons or what disruptions can we see in fintech is, obviously the stumbling block has been regulations in each country and the existing compliance requirements. So the analogy we are drawing really is from AgTech, where the compliances are very lesser, right? So there are not as many stricter compliance apart from copyrights, trademarks, fair use policies, which a search engine like Google would adhere to, right? So some of the like when you're talking about, let's say, banking on blockchain, I'm coming from Nvest Bank, which is a crypto bank. It's a physical bank where people can walk into, and the platform runs on a distributed ledger technology. So people also, like say, the youth is already used to the apps, but what about the 35 plus demographics? Right? They still need a physical bank where they can go to and they get a personal banker to explain them the product and onboard them onto these platforms. So we have a chain of physical banks started at Toronto and then moving to Seattle and New York. So currently we are building the products and the platforms out of Bangalore, the R&D center in Bangalore. So these are some of the topics we are working on. It's like banking on blockchain is the broad the vision, and so decentralized credit scores, payments is one of the low-hanging fruits in fintech. But apart from that, what are we doing is decentralized credit scores, pension funds. How can we bring pension funds, which is one of the huge use cases for like the long-term funds which you can get from people is like pension funds, insurance. You have credit identity, which is like for KYC compliance, and how can you bring identity with like a decentralized Aadhaar. Then of course the BFSI and the central banks itself, right? So you're not reliant on a central bank for the currency or the asset which is created. So we see this as a Uberization of the bank, but it's a decentralized Uber. And also the tokenization, which is like disrupting VC models, is like the tokenization of these blockchain platforms and blockchain economies, and the barterizing, digital bartering of the economy. Right? So we're moving back to what was the existing systems. So when these, the complexity of a decentralized village became too huge, a bank or a empire stepped in to fill in that gap by printing a centralized currency and a centralized institution. But with this sort of a platform, you're seeing the re-emergence of the barter system. This is like a token for each of the individual functions in an economy. So the lessons we draw from the ad tech industry is very clear. How many of you have heard of the Brave browser? Right? Quite a few. I mean, like whoever is following the latest upcoming ICOs, right? So Brave browser is one of the ambitious projects which wants to basically take Chrome browser and make it a much more privacy preserving model where you're not distracted by advertisements, and the publishers also get remunerated for, and you can opt into the relevant publishers and they get a monthly payout, so they don't have to distract you from what you are reading on the web pages. So Brave browser is one such platform, and so these are the lessons which we get right from ad tech industry. This has already moved and it has a few million downloads already, and people are quite a few publishers already onboarded on the platform. So so this basically the premise is the privacy preserving web model, right? So this already shows how you can earn rewards by browsing your regular set of sites, and there is a Brave attention token which basically measures how much time you spent on each of the individual sites and distributes your wallet balance onto each of the publishers whom you are visiting on a monthly basis. So it's a pull model opposed to the push model of the distraction web. Is basically a push model where they guess what you want, right? Like an insurance ad or a loan ad is basically taking a guess that you're interested in the product. It's not really an opt-in product. Whereas this is more of opt-in product where you can opt into those services, so you only see relevant ads. So this is one more possibility with fintech, is that you can opt into publishers, you can opt into offers, relevant offers, rather than being bombarded by ads which are not really targeted at you. So this is an experiment we started at our R&D lab. Is a decentralized Google, call it Doodle. Is basically, can you take this data, users' browsing history, users opt-in ads, and create a decentralized version of Google, because that is what we are inspired from, is from life after Google, life after Facebook. So this is one app we created out of IPFS running locally, but it's a work in progress. So coming back with some startup or some existing innovation hub in a corporate wants to know how they can leverage this decentralized AI, and what are the problems with the current model. So the AI business model currently is basically you acquire data, about people. You train a model which does something useful. It could be like recommending the nearest Uber app or a relevant product you want to buy on Amazon, and you make use of the model. Right? So it's the current centralized app ecosystem which you are already aware of. Right? But there are problems with this model. Right? People give away the control of the data, so the control of their privacy to these apps. So these are the problems. There are risks with that. It could lead to theft, resale, right? So just like last week, I think around 773 million emails were leaked. And before that, Equifax, which maintains your credit scores, your credit history was hacked. So there's no end to these. This is always an inherent risk with centralized systems. So how can you prevent that, right? So your privacy is at stake, and fintech data is much less valuable than healthcare data, right? So these lessons are also applicable to healthcare, where you have much more valuable data about people and lost natural income, right? If you're browsing and training Google to become better at prediction, you are not really being compensated for that work, right? But what you're doing when you're clicking those links is basically you are training the Google model to become better, but you're not being compensated. Whereas in a Brave Attention token, you are getting compensated. So these are the sort of models which are missing out in the current AI business models, which can be done, right? Sensitive products, right? So you don't want to know that you are suffering from a disease so that your insurance premiums go up. I mean, that could be a valid reason, in fact. But if there is some more sensitive data which you don't want a centralized player to know, like an Amazon, you want to buy something, it could happen that Amazon knows you are interested in that and will jack up the price the next time you go and see that, right? So these are some problems with sensitive products. And then there's the aggregated part, right? Like I said, data oligopoly, centralized all this data, and that leads to aggregation of power. And the inner concept of the blockchain, some of the utopian ideas are about decentralization and disaggregation of power, right? So the success criteria. So how can we define that if these are the problems, the model we are coming up with is successful, right? So we would measure it based on these factors, like privacy. If people should be able to maintain control of their data, it's like if you hold bitcoins or Ethereum, you hold the private key. So that is, it's not like a wallet parking where you give away the keys to a central exchange and they maintain it. You maintain it just like you would do it on a decentralized exchange. Right? So the privacy, if you hold the keys to your data, then you are the owner of the data. Income, people should be able to earn passive income of the data because when we say data is like oil, it is like any asset or a resource. So when you are sharing the data with opting into publishers or financial service providers, you should be able to earn passive income out of the data. When you opt in to receive loan ads or insurance ads or mortgage ads, you should be able to profit off that data. Sensitive products. So in a decentralized AI where privacy is not compromised, you will be able to not leak sensitive product information or sensitive data. So those can be built in a privacy preserving way. Right? Decentralized power, so it leads to greater decentralization of power because there is no data oligopolies formed. Then it's productizable. So people are already used to all these facilities which recommendation systems provide. Some people say, no, I don't want to use ad blocker because I want to see the recommendations. Right? So in a decentralized AI, you are still able to make those recommendations in a decentralized way. So how do we go about envisaging a solution? Right? So what will be the ingredients for such a solution? Deep learning, so that is our model based off, it's based off deep learning. And then there's federated learning. 2016, Google produced a blog post where they themselves understand that their centralized business models are under threat. So what is the alternative is a federated learning model. So they now have TensorFlow working in a federated learning setup. So for workshops we do a Python demo, but I think we can just stick to the conceptual clarity for these sessions. Deep learning libraries. Right? So what does a deep learning model actually do? Right? So it takes an input data set. It could be previous transaction history to predict what is the creditworthiness and how much of a loan can be given to this person, right? So that is the deep learning model requires a data set, and based on the features it is trained to give a prediction whether the credit score of the FICO score or the CIBIL score of this person is greater than 70, then he qualifies for a loan. If it is less than 750, it doesn't qualify for a loan, right? So some sort of a model like that where you have a data set and you have a model from past history where you have trained it. So if a person's CIBIL score is more than 750, he gets, if it is 650 to 750, maybe he pays a little more interest premiums, interest EMIs to service the loan. So how does DL work? So you create a random function and then train the prediction to become better as in more and more data is given and it becomes better. So is the prediction too high, too low? So you correct it along the way and then you tweak it and then that is the best model you have based on the current data set, right? And this is what it is like. Pictorially, if you are recognizing cats and dogs to images, you train the model, give it like images of cats and it becomes good at predicting what's a cat, what's not a cat. So if you give an image of a dog, it says, cat, it's not a dog, it's not a cat, right? So that is how a deep learning, I mean, machine learning itself is very vast, right? So there is vision, there is speech, there is so many subtopics like text. So for the purpose, our purpose, we can imagine a neural network, right? So there are deep learning libraries which you would know, PyTorch, TensorFlow, Keras, Caffe, which we can be used as the ingredients for a decentralized AI solution. So like I said, what is federated learning? Federated learning is, like I gave the example of predictive typing, right? So you have all these mobiles which are sending the adjusted weights, and there is a meta model which is becoming better, which is then used to adjust the weights for your local model, right? And therefore you get a different prediction from some other person who is typing the similar letters, right? So this is federated learning. User downloads a model. Users train the model on their own data, whatever you are typing, and then the gradients is like the differences between the parameters, the weights of the parameters. So those gradients are sent to a server. It could be a centralized server or it could be a decentralized server setup. So what we are trying to build up is in a decentralized server setup, and then the gradients are summed to protect privacy and the model is updated in the cloud. Right? So if it is a centralized Amazon server, it will be the cloud. If it is a decentralized model like an IPFS storage where the hashes are stored on Ethereum blockchain, that could be a decentralized version of it. So federated learning models like Apple and Google, Android, Gboard or Apple keyboard have these federated learning platforms already for their keyboards, right? So homomorphic encryption is the third and one of the vital components. So how does it work is, so basically you have, let's say, two numbers 3 and 5. So that is like the unencrypted text. You apply homomorphic encryption and you get a ciphertext A, ciphertext B. And when you multiply that ciphertext A with 2 and you use a homomorphic decryptor, it knows that is 6, right? And if you add cipher A, cipher B, you get 8. So the operations are being performed on the ciphertext or the encoded text, right? So the algorithm is able to work on encoded encrypted data. So there is no data leakage is one, so your data is private. So the model is able to work with encrypted data, right? So all your regular algorithmic operations are able to work on encrypted data, so your data is not really compromised. And the other part of it is like basically your models are also encrypted. So if a data scientist is publishing his model, right? So different data scientists, like in a Kaggle contest, right? They can create their own machine learning models, and publish it on IPFS and issue a smart contract if a DApp uses that model and that model is encrypted and your data is encrypted. So the data scientist model is also not leaked and your private training data is also not leaked, right? And in this way you could like basically preserve the privacy of not just the model but also the user state. So how does homomorphic encryption work? So you have the plain text, ciphertext, you have public keys and private keys to control and operate that data. And I mean, without going into too much of mathematical details, so these are the cryptographic ways in which it uses cryptographic primitives just like a zero knowledge proof would use, right? So it would use similar cryptographic primitives to accomplish the task. It uses encryptor, decryptor functions, and so that is it. So we have quite a few libraries in various languages which you can use to use that functionality of homomorphic encryption. And of course, like, so there has to be an incentive model and governed through well-known smart contracts, which basically facilitate this new decentralized AI model, right? So you have all these data sets which are provided by individual users, and you have data scientists publishing their proprietary AI models. So the AI models are, let's say, on IPFS, and they are attached to a smart contract, and the DApp invokes the APIs of the machine learning models, and the user provides the training data. So everybody needs to get incentivized, which is like governed through the smart contract. So you have the data, the state, the code. So, and you have a large distributed data set. So if the data set is large, you have a training data which is not given out for, you need to know that the user is not submitting data which is like corrupting the model, right? So you need to have a standard. So you can store that on an IPFS operated by the data scientist. So each time a user uploads his data, training data, you measure it with the existing accuracy of the model. If the accuracy goes down, you know that it is like a data which is not adding value to the model. So you either impose a penalty or a disincentive for a user to tamper the training set, right? So these are ways you can ensure that your model in a distributed way, each individual's data is getting better and better. So that way the data scientist model keeps getting better, and the DApp, which relies on that distributed ML model, also gives better recommendations to its user. So the DApp pays a fee to the model's owner, which is the data scientist, and the data scientist pays a fee to the end user, because the end users are helping the model to become better, training the model to become better, and that is how the economy is incentivized, right? So unlike ICOs, right, when they create a project in an ICO, which is there is no way to objectively measure whether ICO A is better than ICO B, whereas in a decentralized machine learning app, it is very easy to objectively measure what is the accuracy of that model, right? So you have this ecosystem of ML, DML apps, dApps, which have a very objective measurement, right? So the accuracy of the model. So for the first time, if somebody can like circumvent all the problems associated with objectively ranking ICOs, right? So you have ICO bench where people crowdsource ratings, rankings, but it could be gamed. But you now have a system where every DApp has a machine learning model attached to it, which has a very objective scope. Right? So each time it's very easy to classify and rank. Is Google actually better than, let's say, DuckDuckGo, or or they are just people used to Google that they keep using Google, right? Is it for a large number of people, which app is performing better is very objectively measurable. So that is one side effect of what we can create with this decentralized machine learning ecosystem. Right? So the smart contracts enable the incentive systems, and these are the outlines. So, but if you we need to use all of those 4 ingredients for the recipe, right? Like you cannot just have some parts of the system, because then we will fall back on the centralized model, right? So you need all, right? So if in the existing legacy system, people lose control of their data, right? So like I said, some services are creepy, like data is a natural resource, so you don't want to lose any of that. So all the ingredients are, like I said, deep learning, federated learning, homomorphic encryption, smart contracts, blockchain. And so this is how, if you want to visualize it pictorially, you have a corporation called an AI Inc., which has Jack's data, Joe's data, Jane's data, and it will be used those data sets, right? So you could maybe download your LinkedIn data set, Facebook data set, or your medical data sets, your banking data sets, and those data mines what will give you passive income. Right? Each time you opt into a data scientist's model, the smart contract would govern, like each time the data scientist gets paid by the DApp developer, the smart contracts gives a part of that incentive to the end user of the data, end owner of the data. Right? So this is the way you would create a solution. So gradients gives him, but if you really don't incorporate homomorphic encryption, like I said, the gradients when you are sending away, like this person is from Bangalore, is like a hint about where this person is from, or if this person is like age 25 to 35, that is a hint on what is the age group. Gradients are like, if the standard model is 35, it sends, if a person says 25, the gradient is at -10, which is sent to the model to adjust the weights. Right? So you could have managed the middle attacks even in a decentralized way, where there are eavesdropper nodes which will listen to these gradients and basically carry out man-in-the-middle attack. So you want to avoid that, and that is why you cannot just have, let's say, deep learning and federated learning like Google has, right, or wants to create a roadmap. You still need homomorphic encryption. Right? So you need homomorphic encryption of not just the data but also the model, so that the data scientist model is also not leaked out. Right? So this is basically a reiteration of what we discussed earlier. So we have an AI Inc., we have neural nets, or these are the models, and the data sets of each individual user. This could be mobile phone data, this could be medical data, this could be financial data, is used by this network to train the models and facilitate the users. Right? So the smart contracts completes that loop and incentivizes each person in that user, because it also plays, the economic layer plays a very important role, because if somebody is sending in data which is tampered data, the model knows that this is not improving the accuracy, right? So the smart contract would then penalize that person for sending malicious data. So how can I build this, right? So that is, like, this is the what, we just discussed what of it, and we've identified some libraries which can be used to build it. So one popular open source library which we are inspired, right? For this talk largely derives from OpenMind. He was a PhD student from London, created OpenMind, Andrew Trask, and there is a library called SIFT, and PySIFT is the most actively developed branch of it. You can look at it as being actively developed to help facilitate homomorphic encryption in a decentralized way. And then there is a grid, like Ethereum blockchain, there is a grid which is being built, which is really in alpha stage, in a conceptual stage. So I would request everybody to look at this and take part in this, because it's a very new way of organizing society, right? Or new way of organizing a blockchain-driven economy. So this is open source software. So what can you build with it, right? So what is the deal for Fintech? Like we identified, the imagination is the limit. Like, so some of the areas we are working on as a crypto bank and decentralized crypto exchange is algorithmic trading, right? Like, currently algorithmic trading is plagued by high frequency traders who basically capture the trades and execute the same trades by jacking up the prices, because they are located close to Chicago or some of these exchanges, and they are connected closely and they are in the same room, right? So these are some of the problems which high frequency trading creates in markets. But whereas if it is driven by an exchange like Ether Delta runs on Ethereum smart contract, so you know that the blocks are finalized every 10 minutes, right? So you cannot have these high frequency traders who will capture intermediate data and rig up their prices, because they still have to wait for that window of 10 minutes. Right? So these are some of the proposals which have been suggested to prevent high frequency traders from executing these trades, which are right. So Quantopian comes basically tries and crowdsources algorithmic trading. Right? It's again another Python platform where you have one side which is the algorithmic developer who comes up with a strategy of how we can do a trade like a clock, like he wants to go big on Apple or go big on Ethereum because it's an all-time low, so he comes up with an algorithm which will people can invest in, right? Like, and on the other side you have investors who look at these strategies or the track records of these developers, and then they take a bet. Okay, I'm putting my, just like a mutual fund, you take a bet on the developer and you invest in that, right? And based on the performance you get rewarded. But currently the Quantopian platform is centralized, but you can take the same model and further decentralize it by making it run on Ethereum, and the same platform can run on any other custom blockchain. Right? So algorithmic trading is one area we are actively working on. So decentralized financial market, so you have code basically doing the work of the stock exchange, right, or the mutual fund, or an investment bank, or a hedge fund, right? So these are some of the the areas which are prime for disruption, because we've already been talking about payments, which is cross-border payments, for trade finance, or some of those low-hanging fruits, right? So what next? What next? How can we further disrupt financial markets or investment banking? So that is what we are trying to do. So of course, can we level the playing field of Wall Street market? Because there's like $1 trillion of worth of derivatives and futures and options are there. So the next step would be security token offerings, right? So this chart really talks about ICOs, how ICOs disrupted the early stage financing, right? So angels and VC funding. But similarly, you can have STOs, which are like if people want to invest in futures and options, derivatives. So now they have an option where a bank is running it. So they have wallets, they have a physical branch, which can like do your cold storage, or you can do personalized banking. And if tomorrow they want to get a demat account and trade in securities, so these are security token offerings which are being floated by taking the filing for like D or whatever required permissions are in that geography, and facilitating the further disruption of the investment banking. So these are some use cases we have identified and actively working on. And I would conclude my presentation with that. If you want to connect, I am reachable on sujan@nvestbank.com. If you have any questions, I'll be more than happy to take it. Thanks.
Questions?
So even though this IPFS is still under your control, the INC which you're talking about, the algos which is getting stored in a, so because as you see in the last 1 year, we have seen the algo trading which is completely failed. We have seen the decentralized exchanges is failed. So the reason is there is some other entity who is still managing that. Okay, as long as you can tweak the smart contracts, you still can play around and fool around with the investors' money, right? So that's how we have been. So what do you foresee that how we really can address this problem?
When you say tweak the smart contracts, what do you mean?
In instance, like, so currently you go with one, so ideally it is this technology is completely hidden from the person who is currently interacting with. It's just that your marketing, the way you market across, whether it is a normal trading or another good trading, you do it. At the end of the day, it's in the control of the entity who is managing that, right? Because of that, over greediness, I think we have seen in the last 1 year, so many things has happened, right? So I think technology will work, but being into this area, so what do you foresee in the next 1 year, and how you guys are really working on?
So regarding, let's say, Ethereum, let's say Ether Delta is a decentralized exchange, its volume might not be high because of liquidity problems, but if there is an educated investor, he can go inspect what the smart contract does, right? So that is already there. But like obviously this is not possible for a layman to go and inspect what the smart contract does. So basically you are trusting the brand rather than you taking an informed decision. So that I would say is mostly a investor education, like how we can go verify the smart contracts from the investor side. And from the publisher side, I think formal verification is one area where, like for jet engines, so a jet plane is like millions of dollars, right? So when it is being programmed, it's formally verified that it can only do what it is programmed to do. Whereas a web server web server software or even Ethereum Solidity smart contracts, we don't know what are the edge cases, right? It cannot be, it's not foolproof, right? So if you can bring in similar guarantees just like you have for a jet engine, right? If you can bring formally verifiable contracts, so if you don't really have to trust or go and inspect what the contract does, but at the time of publishing the contract, it passes tests just like you test software, and but a formal verification system which is already there in the academic literature, right? So there have been some areas like Cardano Ouroboros protocol has released something called a K framework, where they give this model of how EVM or Ethereum virtual machine can be formally verifiable using the K framework, right? So these are like theorem provers, theorem solvers, which have already been have been there in embedded systems domain, jet flight simulation software, so that they can actually test that software before it is released into production. But whereas what happens now is people, either the onus is shifted to the person inspecting the smart contract. So regarding smart contract, it is very clear it has to be formally verifiable, because the same stakes which a jet engine has is also tied to the DApp, right? So you have millions of dollars which could be potentially leaked out because there is some bug in the smart contract. So I think formally verifiable smart contracts is one key area I would see, because rather than relying on the brand, it is formally verified, right? So that is one area which I foresee and we are also actively working on that, because with Cardano's Ouroboros releasing the K framework, it is very clear. There is Cardano.
Now it is not actively working on it.
I think it is. I mean, it's one of the top 10.
It's still there, but there is nothing which is happening there.
True.
From platform standpoint, what is happening? Nothing. I don't see any product.
It's just like any other blockchain infrastructure, right? Like it's.
There was so much of praise hype, right?
True. I mean, the valuation is always like a function of how much surplus capital which is chasing these blockchains, right? The investor sentiment. So I would rather see like what is the technology really bringing to the table? Is it? Yeah. So I mean, like the valuation is always like market forces, but something which was discussed in academic literature back in 80s and 90s, like for a web server, how can we make it a formally verifiable, right? But the stakes were not that high to make a web server which is like formally verifiable, just like a jet engine, right? But now with Ethereum smart contracts, dApps, which have millions of dollars at stake, you have the same incentive system to formally verify any piece of software. So I think smart contracts need to go through that process, and because Ethereum being the leading dApp open permissionless platform needs to incorporate these formally verifiable systems, and I think K framework, which has been contributed by Cardano Ouroboros, is a right step in that direction. And if we are able to draw parallels from that and productionize dApps running formally verifiable contracts, that would be a very key value addition to the ecosystem. So you would not rely on a brand like a CryptoKitties or a crypto or any other decentralized exchange. You know it is formally verified, right? It's formally verifiable, so you trust the system rather than putting the onus on the end user. The developer of that app certifies that it is formally verifiable. Just like you go to Etherscan and verify the smart contract, you can go to, let's say, a formal Etherscan. If tomorrow somebody adds that feature to Etherscan, somebody go and check if it is formally verified. Right? So that sort of a feature, I think, would radically build much more trust into the ecosystem, and will, as a consequence, the valuations will fall. Any other questions?
Well, I think that'll be all then. Thank you so much, Sujan. It was indeed a great presentation. In fact, I had another speaker cover the marriage between AI and blockchain in Mumbai, which was interesting. Yet again, an interesting presentation to conclude things. So this certificate, Sujan, rightfully belongs to you. So can you... All right, friends. Yeah. So, like I said, all these presentation slides would be shared with all the delegates, and I hope that you have enjoyed all the sessions today, because we have tried presenting knowledge by way of presentations, use cases, how ready are different industries to adopt many of blockchain's applications. So we have tried to, cater to all these touch points, and we hope that, all of you have learned something today. And of course, once the presentation slides are shared, you will be having the coordinates of all the eminent speakers that presented today. We look forward to more of your participation in the future. We have given you the brochures that also contain the conference calendar and the forthcoming events. So those of you who have already attended the session today and also the session last week, that is on AI machine learning, you would be given special discounts for our future conferences. So in case you're interested, you can write to us at info@pyramidplatforms.com. On that note, I would like to thank each and every one of you, the delegates, for making the day so special and interactive, and all the speakers, the ones that are here and the ones that have left, for significantly contributing to add to each one's knowledge base. Thank you very much, and we hope to see you soon. Have a great weekend ahead, though it's a Thursday, but I would definitely want to wish you a good weekend. Please do fill out the feedback forms and kindly collect your participation certificates. My colleague behind, Deepshika, she will be helping you out with those. Thank you very much.
Thank you.